Tungsten. Oh my. Okay. Then if I have to write this, everybody can write it with me. Get out a sheet of paper. Oh, no, 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 no. It's too late now. Let's do it.
What are we doing?
Tungsten.
Oh, no. But we've done tungsten.
I don't care. We're doing it anyway.
Okay.
Get with the program. Let's have. If I'm going to suffer, we all suffer. So I'm writing the orbital notation for tungsten here, which we've done this kind of stuff a lot. You need to know that after you get to 4s, you got to drop down to the third primary level to start D. So 4p. Alright, see, I'm at krypton now, so I need to go to rubidium next. Starting where yttrium is. Then we're going to go back to 5p. And I will come back down here for 6s. Let's move out here down just a little bit. Alright, so right now, 1, 2, 3, 4, 5, 6. I'm right here and I'm trying to get to right here. Okay? So we're starting with cesium here. Cesium and barium, and then we're going to go to 5D. I'll put one electron in there for lanthanum, and then I got to go down to 4F where I start cerium. And I need 7 of these orbitals. So I finished up down here to lutetium. Going back up here to hafnium now to put an electron here. An electron here for tantalum. And finally electron here for tungsten. And tungsten is the exception to the exception. Normally when we get to this point, where we've got a nearly full D sublevel, we always pull the electron out of the next highest S sublevel. We did that for both molybdenum and chromium, but we're not going to do it for tungsten. Okay, once I introduce the F sublevel, there's something funky happening there that keeps that from happening. Okay? Move it over. Alright. So now we need to pick an electron. Wait. Don't tell me. You're kidding? I'm not. Okay. That's a radio show, by the way.
Really?
Yes. Wait, don't kill me. Don't tell me. No, it's an American radio program, but it's on NPR radio. It's a news quiz they do every week.
I think there's a show on BBC.
Really? Could be. Okay. Let's pick an electron. Anybody want to pick an electron?
That one.
Uh-huh. Not very helpful. All right. Well, I'll pick an electron then. Let's do this one right here. Let's do that one right there. Okay? The second one in 4F. Okay? The second one in 4F. Alright, so there are 4 quantum numbers symbolized by these letters, or symbols. N, L, M sub L, and M sub S. Okay? N is the primary energy level that electrons found in. Well, that electron's found in the primary energy level number 4. So N is 4. Okay? L tells you what sublevel you're in. And the sublevels S are always zeros. The sublevel P's are always ones. The sublevel D's are always twos. And the sublevels F's are always... Okay? So you're going to have somebody over there thinking it's true and they're going to mess up on the test tomorrow. Let's be careful.
Monday.
I'm sorry, not tomorrow. You're right, Monday. Okay. M sub L is which orbital the electron is located in. Now I'm going to repeat myself for about the umpteenth time here, but there really is no direct relationship between where we put these boxes or these squares and which M sub L quantum number it is. But for convenience, a lot of teachers do this. We just number it this way. Since we know the numbering system always has 0 in the middle and goes down in whole numbers into the negative side of things and up in whole numbers in the positive side of things, then we number them like this. We say that this orbital here in the middle is 0. This is -1, -2, and -3. And this would be +1, +2, and +3. Okay? That's the numbering system for orbital notation. Numbering system for quantum numbers, okay? So since this electron we're looking at right here is in the orbital that we're going to call -3, that's what it is, okay? And then since it has a down arrow, that represents a -1/2 spin in the quantum number system, okay? How are we doing? Anybody have trouble with that? All right. Yes. Do what? Could I do quantum numbers for electron configuration? I could figure out the first 2 quantum numbers from electron configuration, but I can't figure out the last 2 quantum numbers because, well, no, wait a minute, hold it. Yeah, because the electron configurations don't show individual orbitals, nor do they show the spin of the electrons. Okay? That make sense? Or do I need to draw it out for you and show you?
It makes sense, but one of these questions... Okay, never mind.
That makes sense now? Yeah, I think I know the question you're asking about. And it said, what part of quantum numbers is related to that, right? Mm-hmm. Well, the first quantum number, n, is related to the coefficient number in both orbital notation and electron configurations. The second quantum number is directly related to the sublevel, the little letter S, D, P, or S, P, D, and F in both orbital notation and electron configurations. M sub L has a somewhat direct relationship to orbital notation in that we could assign those numbers to these boxes here, or these squares, but there's no direct relationship between any part of an orbital notation and the third quantum number. Okay? Likewise, actually the down and up arrows do have a direct relationship to this. So there's a direct relationship between the fourth quantum number and the up or down arrows in orbital notation, but no direct relationship between this quantum number and electron configurations. Okay?